Hello all. Definition of digital twin in the product lifecycle. Digital twins continuously capture people's attention across a variety of industries and represent a key tool for optimizing design, manufacturing, and sustainment of complex systems. On the other hand, service-oriented business models and virtual product development require knowing the condition of product at all the times. The emergence of a digital twin from product lifecycle management was first described by Mr. Michael Greaves in 2002. He said, every physical product has a virtual counterpart and that both elements are linked to each other through a continuous exchange of data. And that's one of the definition. And in the other way, digital twin is a sum of all the simulation models that describes the function and behavior of a product. Despite of the wide range of possible application of digital twins, there is currently no universally valid definition. So I go with this two based on the application. When coming to a part of the PLM, key part of the PLM, the BOM structure, the bill of material structure, and the RFLP requirement, functional, logical, prototype, nothing but the geometry, and the integration informations, and the traceability, all these details are uh, present in product lifecycle management tool. And especially when we're coming to a as design structure, the engineering BOM, that will support us giving all the bill of materials. Here, so for example, we'll just start from the as designed one, the engineering BOM. That's one the initially we just move on with the assembly H and the part I are getting multiple versionized, multiple revisionized when it's connecting with going into the multiple other stages as planned, as built, as maintained in the way of digital. It's product throughout its entire service life and contains the latest product information at all the times. The digital twin encompasses all phases of the product development processes and the downstream phases during the product use. This can be divided into three overarching life phases of product. That's what as designed, as built, and as maintained phase. Usually the as built system, that's where the digital twin gets born, meaning that will be living with 100% BOM when we're getting simulated. Usually in the as designed, we have 150% bill of material. So that's getting reduced to 100% BOM. So the no variances, variance free product configuration only will support in the digital twin. So that way in the later stages we are not changing the bill of material. The material can change, but the same part cannot be repeated twice. So those kind of functional challenges can be avoided. So the traceability, these blue lines, the ability to trace connections and dependencies between information that arise during the analysis and maintenance and further development of a system at any time. This is the only way to trace changes backward and forwards. To ensure this, it is necessary that any kind of evolution of a digital model and digital twin is versioned. We'll just see that in the next diagram as well when we discuss it in detail. And the complete trace link information. This is what called the digital thread throughout all the phases: concept, design, development, and product manufacturing and services. The entire in the entire cycle throughout the trace link. This continue every information right from the bill of material, right? All the each BOM line informations like what is the material information and what the position information, everything, every information. It's like a chain. It has been traveling together. So that's a digital thread. There's a heavy connection of digital twin and digital thread. It's been sourced from ARAS and mm, There are multiple levels of digital twin, like how far we are taking the information or analyzing the information. So the first level is components or individual parts, and machine level, the entire machine or a sub assembly or something. And then the fleet level is several machines or several systems, multiple systems into one into one digital twin. So the first, as we said, like the first physical twin getting born in that stage of as built. So that's in the real world. We'll build the physical parts uh, pertaining to the digital twin part. So the digital twin first version and the physical twin first version getting introduced with the as built stage, and then it is again in the as maintained stage. We'll be getting more information from the IoT platform of all the when it is in the operational stage. We'll be having many inputs from the physical model of all the details. So we are just getting the cascading the back into the development stage. If anything, any product information can be improved. So um, and product design, manufacturing, and services are the areas of application. And when looking at the use cases of a digital twin, it becomes very clear that the full benefit can only be realized with the existence of a physical twin. Um, and the bidirectional exchange of data at what we are doing here. If no physical model, then the simulation model can be created, which is nothing but only the virtual model or the digital prototype that can support. Mostly this applies to the new products and new startups. I'll continue with the um, uh, next one with of digital twin elements. Thank you.